you all are fine. In COVID situation, please stay home, stay safe. Welcome to online classes. My name is Rajeswari, mathematics teacher from KGBV Kondapuram, SPSR Nellore district. Children, I will ask one question. Your teacher was entered into the classroom. She asked the students, how many children did the homework yesterday I was given? So, some students raised their hands. The class leader stand up and count the how many children did the homework. She starts to count the hands of the children. 1, 2, 3 and so on. So, we use the numbers for counting is called counting numbers. Called counting numbers. The counting numbers are also called natural numbers. The counting numbers are also called natural numbers. We denote the natural numbers capital N. We denote the natural numbers capital N. N equal to set of 1, 2, 3 and so on. And we add 0 for the natural numbers. We get the another number set is whole numbers. Another number set is whole numbers. Whole numbers is represented by capital W. Whole numbers are represented by capital W. So W equal to set of 0, 1, 2, 3 and so on infinitely. Children, remember one thing. These natural numbers and whole numbers are positive numbers. Natural numbers and whole numbers are positive numbers. Then we add negative numbers to the whole numbers. We add negative numbers to the whole numbers. We get the another number set integers. So we represented the integers Z equal to set of 0, positive numbers 1, 2, 3 is infinitely and negative numbers -1, -2, -3 infinitely. Children, almost all number sets are represented by first letter of the name of the set. Some number sets are denoted by some various letters. Here, integers is not denoted by I. Integers are denoted by Z. Z comes from the German word. Z comes from the German word Zahan. Zahan. Zahan means numbers. Zahan means numbers. So, we represented the integers Z equal to 0, positive numbers, negative numbers are infinite. Children, I will ask the one question. You are going to the market and buy 1 dozen of banana. You buy 1 dozen of banana. So, the cost of 1 dozen banana, the cost of 1 dozen banana equal to 34 rupees. 1 dozen banana equal to 34 rupees. Now, what is the cost of 1 banana? What is the cost of 1 banana? That equal to 34 by 12 rupees. 34 by 12 rupees. Here, 34 is not completely divisible by 12. 34 is not completely divisible by 12. So, 34 by 12 is not a natural number, is not a whole number, is not a integer. It is not a integer. Here, we discuss another example. You and your friend go to the bookshop and buy 5 pens. The cost of 5 pens equal to 22 rupees. The cost of 5 pens equal to 22 rupees. Now, what is the cost of 1 pen? What is the cost of 1 pen? That equal to 22 by 5 rupees. 22 by 5 rupees. Here, we observe that 22 is also not divisible by 5. So, 22 by number is not in the group of natural numbers, not in the group of whole numbers, not in the group of integers. These two numbers in the form of P by Q. These two numbers in the form of P by Q. These numbers we called as rational numbers. We called as rational numbers. Now we will discuss what is rational numbers. We will discuss what is rational numbers. What is rational numbers? Rational numbers are represented by capital Q. Rational numbers are represented by capital Q. The rational numbers, why represented by Q means the rational numbers also called quotient numbers. The rational numbers are called quotient numbers. So, the definition of the rational numbers, Q equal to set of, the number is, we represent the x is in the form of P by Q, x is in the form of P by Q. Here, two conditions are there. What is there? P and Q are integers. P and Q are integers and Q not equal to 0. P and Q are integers and Q not equal to 0. Which means we take the numbers in the P and Q places. What is the integers? Integers means 0, positive numbers, negative numbers. 0, positive numbers, negative numbers. So, we take the places, we take the numbers in the P and Q places, positive numbers, 0, negative numbers. But Q not equal to 0 means where is the Q in the P by Q form? Q is in the denominator. Q is in the denominator. So, we take 0 in the denominator, we cannot do the division. 0 is taken in the denominator, we cannot do the division. So, Q not equal to 0. In our 8th class mathematics, first chapter is rational numbers. First chapter is rational numbers. So, the rational numbers in this chapter, we have some topics are there, some subtopics are there. First one is properties of rational numbers. Properties of rational numbers. Second one is rational numbers lie on the number line. Rational numbers lie on the number line. Third one is representation of rational numbers. Representation of rational numbers in decimal form. In decimal form. Okay children, today we will discuss in the In our earlier classes, 6th and 7th, we also learned the properties of the natural numbers and whole numbers and integers. Now we will discuss properties of the rational numbers. So, first property is closure property. First property is closure property. So, what is the closure property? What is the closure property? So, the closure property means we take two numbers in any number of set. We take two numbers in any number of set. The two numbers we add, subtract or multiply or divide. The two numbers when we add or subtract or multiple or divisible. The result had in the same set. The result having the same set. The numbers are closed on the variable. On the belongs to properties. So first one, closure property under addition. Closure property under addition. So we take two numbers, that is 2, 1 by 3. We take two numbers, that is 2, 1 by 3. So these two numbers we add 2 plus 1 by 3. 2 plus 1 by 3. So 2 is not in the P by Q form. Here we write by 1. So 2 is in the P by Q form. Now we add these two numbers. First of all, we calculate the LCM of the denominators. Children, first, before we add the numbers, I will tell one thing. That is LCM of the numbers. In earlier classes, you know and learned the LCM and HCF of in 6th and 7th classes. Today we recall that LCM. So I will tell first thing is the denominator of the two rational numbers. The denominator of the two rational numbers is 1 and any another number. 1 and any another number. 1 and any another number. We will get the LCM. Is another number. That means we will take the numbers 1 and 3. So the LCM is 3. We will take the numbers 1 and 10. The LCM is 10. We will take the numbers 1 and 25. The LCM is 25. Here we observe that the denominators of the rational numbers 1 and any other number, we will get the LCM of another number is the LCM. Second thing, the two numbers are multiple each other. The two numbers, one number is multiple to another number. One number is multiple to another number. That means we take two numbers 2 and 10. We take two numbers 2 and 10. Here 10 is the multiple of 2. 10 is the multiple of 2. So we get the LCM of 2 multiple of 8. Now we get the LCM is 24. Okay children. Now I will tell another thing. Third one is the denominators of the rational numbers are equal. The denominators of the rational numbers are equal. We will get the same number as the LCM. We will get the same number as the LCM. 2 by 4 and 6 by 4. So we will get the LCM is 4. Next last thing. We take the two numbers. The denominators of the two numbers is co-prime numbers. The denominators of the two numbers is co-prime numbers. We will get the LCM is multiple of those two numbers. Multiple of those two numbers. That means 2 into 3 equal to 6. 2 into 3 equal to 6. So we will get back. We add 2 by 1 plus 1 by 3. Here, look and see. The denominators is 1 and 3. 1 and 3. Now we will discuss the LCMs. So here 1 and 3 LCM is 3. 1 and 3 LCM is 3. Now we see the first number 2 by 1. The denominator is 1. 1 is divisible by 3 times. 1 divisible 3 by 3 times. So 3 2s are 6. Plus here the denominator is 3. 3 divides the 3 one time. 3 divides the 3 one time. 1 ones are 1. That equal to 6 plus 1 7 by 3. 6 plus 1 7 by 3. Now we will take another example. 1 by 4, 2 by 5. Now we add these two numbers. 1 by 4 plus 2 by 5. That equal to, we add these two numbers. First of all, we calculate the LCM of 4 and 5. So these two numbers are co-prime numbers. We will get the LCM. We multiply these two numbers. So 4 5s are 20 is the LCM. Here the denominator is 4. 4 divides 20 5 times. So 5 ones are 5 plus here the denominator is 5. 5 divides 20 by 4 times. 4 2s are 8. That equal to 8 plus 4 by 3 minus 6 by 4. That equal to, here the denominators are co-prime numbers. We multiply to calculate the LCM. 3 fours are 12. 3 fours are 12. So 3 divides 12 by 4 times. 4 fours are 16. Bracket means multiplication, minus into minus plus. 4 divides 12 3 times. 3 6 are 18. Now we add these two numbers. 16 plus 18, 34 by 12. Children, let us observe. We take two rational numbers. The result also rational number. Next, we take two rational numbers. We subtract the result also rational number. Now, we finally conclude that the rational numbers are closed under subtraction. The rational numbers are closed under subtraction. Now we do this property under multiplication. Now we do this property under multiplication. We take two rational numbers. 4 by 3, 1 by 5. So we do the multiplication between the numbers. 4 by 3 into 1 by 5. We multiply the rational numbers. Directly we multiply numerator with numerator, denominator with the denominator. So 4 ones are 4, 3 fives are 15. So 4 by 3, 1 by 5 are rational numbers. 4 by 15 also a rational number. Next, we take another rational numbers. 6 by 9, 2 by 3. So we will multiply 6 by 9 into 2 by 3. That equal to 6 2s are 12 by 9 3s are 27. Here the result also a rational number. Finally we conclude that the rational numbers are closed under multiplication. The rational numbers are closed under multiplication. Next, we will do the closure property under division. We take two numbers, 7 by 2, 9 by 3. 7 by 2, sorry, 9 by 5. 7 by 2 and 9 by 5. 7 by 2 divided by 9 by 5, that equal to, we do the multiplication on the rational numbers, divided by symbol, change it into multiple. We write the reciprocal of the 9 by 5 is 5 by 9. That equal to 7 5s are 35 by 2 9s are 80. Here we take two rational numbers. The result also rational number. We will take another example. 0 on 8. 0 on 8. So 8 divided by 0. 8 divided by 0. That equal to 8 by 0. That equal to 8 by 0. Children, look at these number 8 by 0. We can't do division with 0. We can't do division with 0. Because the rational numbers not close, under division. The rational numbers not close under division. We accept 0 from the rational numbers. The rational numbers also closed under the division. The rational numbers also closed under the division. and addition. Next, we do the subtraction. Take two numbers 7 and minus 1 by 3. 7 and minus 1 by 3. So we subtract these two numbers 7 minus 1 by 3. 7 minus 1 by 3. That equal to minus 1 by 3 minus 7. Minus 1 by 3 minus 11. Here we write by 1 to change into the p by q form. The LCM of the 1 and 3 is 3. 1 divides 3 by 3 times 3 sevens are 21. Minus into minus plus 3 divides 3 by 1 time 1 ones are 1. That equal to the LCM of the 3 and 1 is 3. 3 divides 3 by 1 time 1 ones are 1. Minus 1 divides 3 by 3 times 3 sevens are 21. Here 21, 1 are positive numbers. We add these two numbers. We get the answer 22 by 3. Here 1 and 21 are negative numbers. We add these two numbers also. Minus 22 by 3. Here LHS are not equal to RHS. LHS are not equal to RHS. So we conclude that rational numbers are not commutative. Rational numbers are not commutative under subtraction. Rational numbers are not commutative under subtraction. Next, we do the multiplication. Take two numbers 3 by 2, 1 by 2. 3 by 2, 1 by 2. So we do the multiplication 3 by 2 and 1 by 8, that equal to 1 by 2 into 3 by 2. 3 ones are 3 by 2 8s are 16. That equal to 1 3s are 3 by 8 2s are 16. Here the LHS equal to RHS. LHS equal to RHS. We finally conclude that the rational numbers are commutative. The rational numbers are commutative and multiplication. Next one is division. We take two numbers 2 by 3 and minus 4 by 5. So we do the division 2 by 3 divided by minus 4 by 5, that equal to minus 4 by 5 divided by 2 by 3. First rational number we write as same, divided by changeable into multiplication. We write the reciprocal of minus 4 by 5 is 5 by minus 4, that equal to minus 4 by 5 divided by change into multiple. The reciprocal of 2 by 3 is 3 by 2. We multiply these two numbers, 2 5s are 10 by 2 5s are 10 by positive into negative, 3 4s are 12. That is equal to negative into positive, negative, 4 3s are 12 by 5 2s are 10. Here we observe that 10 by minus 12 is not equal to minus 12 by 10. So finally we conclude that the rational numbers are not commutative under division. Commutative property. Addition. A plus B equal to B plus A for any two rational numbers A and B. Thus, addition is commutative in the set of rational numbers. That is, therefore, for all A comma B belongs to Q, A plus B equal to B plus C. Second one is subtraction. Subtraction is not commutative in the set of rational numbers. A minus B not equal to B minus A for any two rational numbers A and B. Third one is multiplication. Multiplication is commutative 12. 3 divides 12 4 times, 4 2s are 8, minus 4 divides 12 by 3 times, 3 1s are 3, minus 1. 2 by 3 minus, we subtract 1 from minus 20, we get minus 20 by 4. That equal to, we subtract minus 3 from 8, we get 5 by 12 minus 1. Again we subtract these two numbers, we calculate the LCM. LCM of 3 and 4 is 12. 3 divides 12 by 4 times, 4 2s are 8, minus into minus plus, 4 divides 8 by 3 times, 93s are 57. That equal to, we write by 1 to get the ratio number. 12 ones are 12. 12 divides 12 by 1 time, 1 5s are 5, minus 1 divides 12 by 12 times, 12 5s are 60. Now we add these two numbers, 57 plus 8, we get 65 by 12. That equal to, here 5 is positive number, 60 is negative number. We subtract these two numbers. We subtract 5 minus 60, we get minus 55 by 12. Here children observe that the LHS is not equal to the RHS. LHS not equal to the RHS. So finally we conclude that rational numbers are not associative under subtraction. The rational numbers are not associative under subtraction. Now we do this property under multiplication. Under multiplication, we take another 3 rational numbers, 1 by 2, 1 by 3, 2 by 3. So we do the multiplication between them. 1 by 2 into 1 by 3 into 2 by 3. That equal to 1 by 2 into 1 by 3 into 2 by 3. We put the brackets here. First of all, we multiply these two numbers. 1 2s are 2 by, 3 3s are 9. That equal to 1 1s are 1 by, 2 3s are 6 into 2 by. 1 2s are 2 by, 2 9s are 80. That equal to 1 2s are 2 by, 6 3s are 80. Here we observe that the LHS is equal to RHS. LHS is equal to RHS. Finally we conclude that the rational numbers is associative under multiplication. The rational numbers are associative under multiplication. Next we do the division. Next we do the division. We take 3 numbers, 3, 5, 1 by 4. 3, 5, 1 by 4. We do the division between them. 3 divided by 5 divided by 1 by 4 equal to 3 divided by 5 divided by 1 by 4. So we put the brackets here. First we do the division. Second last numbers. We write the 5 by 1 divided by 8, change it into multiple symbol. We write the reciprocal of 1 by 4 is 4 by 1. That equal to, here we change it to the 3 and 5 is in the form of p by q. 3 by 1 divided by symbol, change it into multiple. We write the reciprocal of 5 by 1 is 1 by 5 divided by 1 by 2. 3 divided by 5 4s are 20 by 1 1s are 1 equal to 3 1s are 3 by 1 5s are 5 divided by 1 by 4. Now we write 3 by 1 into 1 by 20. That equal to 3 by 5 into 4 by 1. 3 ones are 3 by 1 20s are 20. That equal to 3 fours are 12 by 5 fours, 5 ones are 5. Here we observe that 3 by 20 is not equal to 12 by 5. We conclude that the ratio numbers is not associative under division. Associative property under addition. Ratio numbers satisfy associative property under addition. A plus B plus C equal to A plus B plus C for any three rational numbers A, B and C. That is, for all A, B, C belongs to Q, A plus B plus C equal to A plus B plus C. Subtraction. Subtraction is not associative in the set of rational numbers. That is, A minus B minus C not equal to A minus B minus C for any three rational numbers A, B, C. Multiplication. Multiplication is associative in rational numbers A into B into C equal to A into B into C for any three rational numbers A, B, C. That is, for all A, B, C belongs to Q, A into B into C equal to A into B into C. Division. A divided by B divided by C not equal to A divided by B divided by C for any three rational numbers A, B, C. So, division is not associative in the rational number. Next property is distributivity law. So, distributivity law over addition. We take the three rational numbers 3, 1 by 2, 1 by 3. 3 into 1 by 2 plus 1 by 3 equal to 3 into 1 by 2 plus 3 into 1 by 3. Here we calculate the LCM of 2 and 3 is 6. 2 divides 6 by 3 times 3 ones are 3 plus 3 divides 6 by 2 times 2 ones are 2. That equal to 3 ones are 3 by 2 plus 3 ones are 3 by 3. Now we add 3 plus 2, 3 into 5 by 6, that equal to, we calculate the LCM of 2 and 3, 6. Here the denominator is 2, 2 divides 6 by 3 times 3 3s are 9. Next 3 divides 6 by 2 times 2 3s are 6. Here we multiply 3 by 5 by 6, 3 5s are 15 by 6. That equal to, we add these 9 and 6, 9 plus 6 equal to 15 by 6. Here we observe that LHS is equal to RHS. We conclude that what is the distributivity law over addition? For all rational numbers A, B and C, distributivity of multiplication over addition. A into B plus C equal to AB plus AC. A into B plus C equal to AB plus AC. Next, subtraction. We take three rational numbers 2, 4, 1 by 5. So we do the subtraction. 2 into 4 minus 1 by 5 equal to 2 into 4 minus 2 into 1 by 5. Here we write the by 1, change into the rational number. LCM of the 1 and 5 is 5. 1 divides 5 by 5 times 5 fours are 20 minus 5 divides 5 by 1 time 1 ones are 1. That equal to 2 fours are 8 minus 2 ones are 2 by 5. Now we subtract the 20 minus 1, 19 by 5. That means 2 into 19 by 5. That equal to, we calculate the LCM 1 and 5 is 5. 1 divides 5 by 5 times 5 8s are 40 minus one, we call these two numbers as multiplicative inverses of each other. 2 into 1 by 2 equal to 1 by 2 into 2, that equal to 1. Minus 7 by 9 into minus 9 by 7 equal to minus 9 by 7 into minus 7 by 9 equal to 1. So, identity, multiplicative identity. 0 is the additive identity, 1 is the multiplicative identity. The additive inverse of A is minus A, multiplicative inverse is A is minus A. The role of 0. If A represents any rational number, then A plus 0 equal to A and 0 plus A equal to A. This reason we call 0 as an additive identity element of addition or additive identity. The role of 1. Multiply any rational number with 1, you will get the same rational number. As the product, we say that 1 is the multiplicative identity for rational numbers. Additive inverse. If A represents any rational number, then A plus minus A equal to 0 and minus A plus A equal to 0. Then A and minus A are additive inverses of each other. The additive inverse of 0 is only 0 as 0 plus 0 equal to 0. Multiplicative inverse. Any two numbers whose product is 1 are called the multiplicative inverses of each other. A rational number C by D is called the reciprocal or the multiplicative inverse of another rational number. Okay children, what we discussed or learned in this class, we once again recall that. We learned the rational numbers. What is rational numbers? The rational numbers are in the form of P by Q. The rational numbers are in the form of P by Q. P and Q are integers. P and Q are integers. And Q not equal to 0. Children, all natural numbers and whole numbers and integers are also rational numbers, because all natural numbers, whole numbers and integers we can write in the form of P by Q. Next, we learn the closure property. What is closure property? We take any two rational numbers, we do the fundamental operations on between two numbers, we get the another rational number. The rational number set is closed under the fundamental operations. Next one is commutative property. Next one, commutative property. So what is commutative property? We take any two rational numbers, we do the fundamental operations of those numbers, we reverse the two numbers, we get the same result. The rational numbers are commutative, we not get the same result, the rational numbers are not commutative. Next one is associative property. Next one is associative property. What is associative property? We take any three rational numbers, we do the fundamental operations on the numbers. First, we add first two numbers and add the third one. Next, first we add last two rational numbers and then we add the first one. We get the same result. The rational numbers are the associative on the rational numbers. Next, we will discuss the distributive law. So two types of distributives are there. First one is distributivity law over addition, distributivity law over subtraction. Next we will discuss identities. 0 is called the additive identity. 0 is called the additive identity. 1 is called the multiplicative identity. 0 is called the additive identity. 1 is the commutative property. Verify the commutative property. Okay children, thank you. We will meet in the next class.